Hello, welcome to math class once again. My name is Olujimi Gabriel. Last time we looked at solid and we look at how we can calculate volume by counting the number of cubes in a particular shape. Now, this moment we'll be talking about angle. And at the end of this chapter, you should be able to identify angle between two lines, interpret angle as the measure of rotation and its measurement in terms of revolution or part of revolution. Revolution simply means when something moves round in a circular manner. Name angles using letters. Measure a given angle to the nearest degree using protractor. And lastly, to be able to construct a given angle using a protractor. Now, angle as rotation. The word angle is used as the amount of turn. For instance, when you turn round a circular table, we call it the amount of turn. This is your initial position. By the time you move to this point, join that point to the center again, you have actually made an angle. That's why angle is considered as rotation. The word angle is used for the amount of turn. Now, the figure below shows the hands of a clock move between 9 and 10 o'clock. Initially, this is 9 o'clock. 15 minutes past or quarter past 9, this is what it will look like. At 9:30, which you normally call 9:30, this is where the hands are. And at 10 o'clock, you can see from 12 back to 12. That means the hand of the clock has complete one revolution. It has complete one revolution. And in so doing, the hour hand has moved from 9 to 10. That is, whenever the minute hand completes one revolution, the hour hand will complete 1/12 of the revolution. Now, look at both hands turn. In 1 hour, the amount each hand turns is different. The minute hand makes one complete turn or one revolution, as you can see here. You can see this is the minute hand. It starts from here and complete one revolution or move in one cycle. Now, this is the hour hand. The hour hand moves from 9 to 10. This is the angle between the initial position and the current position. Look at the amount of turn. You can see it's so small as compared to the minute hand. Now look at the hour hand turn through 1/12 of one revolution. Now moving from 12 back to 12 is one revolution. That is, you move from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Out of the 12 movements, the hour hand only move 1. That is, the fraction of 1 is 1/12. Now, the angle turn equals to 1/12 revolution. And we know the angle in a circle is 360 degrees. That is, when you move round once the circle, you have completed 360 degree turn. When you move round again, that will be times 2. 3 times 3 and so on like that. That is 1 degree equals to 1/360 revolution. That is, you can convert revolution to degree and from degree to revolution as the case may be. Now look at this example. What is the angle between the hour hand and the minute hand of a clock at 1 o'clock? You can see When the minute hand move from 12 to 12, the hour hand move from 12 to 1. That means the number of revolution is 1 all over 12. Now, you now convert this revolution to degree, as we did when we were treating pie chart, when we have to convert numbers to angle. Now, the same thing will be applied here. That is, 1 revolution equals to 360 degrees. Now, convert this fraction of revolution to 360 degrees by multiplying it with 360. That is 1 all over 12 times 360. 12 here 1, 12 here 30. That means the angle turns 30 degrees. That is how to convert revolution to degree. Another example. Find the smallest angle between the hour hand and the minute hand at 2 o'clock and at 3 o'clock. Now, that means the hour hand move to 2. That means it covers 2/12 of the revolution. Now, convert that revolution to angle. That will be 12 over 3 over 12 multiplied by 360, which will give us 60 degrees. The same thing applies with when it is at 3 o'clock. That is, you find the revolution force, which is 3 all over 12. Then multiply it by 360. It means we are actually converting the revolution to angle in degree. That will be 3 over 12 times 360 equals to 90 degrees. That is how to convert from revolution to degree. Now, we now move to naming angles. Naming angles. When lines OA and OB meet at point O, the angle between them is angle AOB or angle BOA. Note, O is the middle letter. Now look at, this is one line, OB. This is another line, OA. When you join them together, they have common points where they meet. Now, this arm is called OA and this arm is called OB. Now, the lines OA and OB are the arms of the angle. Now, the little space between them is the angle. Let me use this symbol there, angle theta. Now, you can call it angle BOA or AOB as you have it here. You can see O is common because it's the middle letter where lines OA and OB meet. Now the angle between OB and OA is called theta. You can use letter to represent it like Z degree. Now, OB is less than 90 degrees, so the angle is an acute angle. From our knowledge from basic class, we know that angle less than 90 is called angle 90, acute angle, Now, AOB equals to 90 degrees. Now, you can see from our previous angle, it was this way. Now, it has turned straight. Now, the angle between them is 90 degrees. Now, this is OBOA. Now, when you have this sign, it means angle 90. That is why we have it as angle 90 degrees. The letter between them is still the letter O. And that angle is called right angle triangle. Right angle, When we get there, we'll talk more about triangles. Now, AOB is greater than 90 degree but less than 180. Therefore, angle AOB is an obtuse angle. Now, this is an obtuse angle. OA, OB. You can see the amount of turn will determine the type of angle you will have between the two lines. But in this case, we have an obtuse angle. Now, we can also have a straight line. Now, when the angle now turns completely, form a straight line, this is when you have two right angles joined together, we have a straight angles. This is angle A, and this is the angle between them. Now, AOB is 180 degree, just like a half circle equals to two right angles. Now, AOB is a straight angle or half turn. So the type of triangle angle we have here. Now, AOB is less than 360 degree but greater than 180 degree. You can see inside is an acute angle, but when you are now considering the outside, we have a reflex angle. That is, AOB from the outside is reflex angle. When you consider the inside is an acute angle because it's less than 90. But when you consider the outside, that means the reflex of AOB is also AOB, but the outside part. When you consider the inside, it is an acute angle. In that case, that angle is more than 180, but not up to 360 degrees. Now, these are the type of triangles that we have. The summary of what we have talked about so far: we have acute angle, right angle, obtuse angle, straight angle, reflex angle, and full angle. Now, angle less than 90 degree, like 45 is not up to 90 degree. Now, angle that is exactly 90 degree are called right angle. Now, obtuse angle is more than 90 degree but not up to 180 degree. Now, a straight angle is angle that is exactly 180 degree. And reflex angle are angle that is measured between 180 degree and 360 degree. You can see what you have inside here is now obtuse. It now depends on the amount of turn that will tell you which kind of angle you have inside, and the one you have as reflex angle. Then full angle, the angle that is exactly 360 degree. Measuring angle. How to use our protractor to measure angle. Protractors is used to measure the number of degrees in an angle. Now, we have two diagrams here. One is semicircular protractor, just like half a circle, when you cut a circle into two. Then the second one is circular protractor. We use both to measure angle. Now, to measure an angle, let's say this is the angle you want to measure. Place the protractor over the angle so that its center, that is this middle point where these two lines meet, this point will fall on this line. We fall at this midpoint, the point at which the two lines joined together, over the vertex, that is, this is the vertex of the angle, and the baseline, this is the baseline, fall on this line. It will be exactly on the baseline. And the baseline is exactly along one arm of the angle. Then from here, you can now count. This is 0. You can see we have underneath, we have 0. At the upper part, we have 180. That is, when you are counting from this hand side to this side, you use the upper number starting from 0. When you are counting from this side towards this side, you use the upper 0 from 0 to 180. But since I'm counting from this side towards this side, then I will use the lower number, which is 0, 10, 20, 30, 40. Now, you now count to where this line falls on the protractor. And on this line, it falls at, this is 10, 20, 30, 40. Middle here is 45. This is where the line comes, that is 52 degrees. That is how to measure. Now, what you have here is 52 degrees. You can see one of the line fall on the baseline of the protractor. Then you count inward, since you are starting from this end. Then where this line falls, that is where you count and stop. Then you take your measurement from there. Now, look at this one. Exactly what I just explained. Count the degree from the baseline to the other arm of the angle. Look at, you have to measure this line. Don't mind my line. This is 0. Now, this is the baseline of the protractor falling on the line. Then you count 0, 10, 20, 30, 40, 50. You can see all those small divisions, they are also numbered. It could be 51, 52. This is 55 in the midway between 50 and 60. Then this is 52 degrees. That is how to measure an angle using a protractor. Example. Measure the size of the obtuse angle POQ. Measure the size of the obtuse angle POQ. That is, you have to measure here. Outside is a reflex angle. Now, look at, you place one arm along OQ. Look at OQ here. You place one line along OQ. Very straight. Then you now count from here. Where it stops, you count. This is, you can see this start from 180 here. You have to use the lower number. 10, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. You can see it falls on the middle line between 120 and 130. That means our angle equals to 125 degrees. You can use the other way around. We have the same diagram here, counting from different angles. You can also start from OP. This is from OP. We started from OQ, then you can also start from OP. We still have the same measurement. You can see it stopped at 125 degrees. That is how to measure the size of an angle using a protractor. Now, constructing angles. We are to construct an angle of 47 degrees using our protractor. Now, look at. Draw a line and mark a point O on it. Let's say this is the line. Then mark a point on it. Now, place the protractor. Let the middle line here fall on it here. Then let this arm fall on this line. Then count from this angle. 1, 2, 3, 4. That is 40. Now, this is 45 here. You can see. So from here, you just put a mark here. Then remove the protractor and join the line together. When you measure, this is 47 degrees. Now look at, place the protractor so that its center is over O, just like we did in the previous example, and its baseline is exactly over the line on this line. Count round to 47 degrees, which is what I've marked here. Make a mark on the paper opposite 17, like what you have here. Remove the protractor and join the line together. Your angle is 47 degrees. That is how to construct an angle using protractor. Assignment. You have to find the smallest angle between the hour hand and the minute hand of a clock at the following times: at 4 o'clock, 10 o'clock, 9 o'clock, and 6 o'clock. Now, for more exercise and more reading, take your new General Mathematics JS1, page 60, exercise 8B, number 1 to 3. Then also go to page 62, exercise 8D. You can try as many as you can. Construct as many as you can. Then make sure you master how to use protractor effectively to measure angle. Till I come your way next time, stay blessed.